Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 3 in the exam objectives and discuss Section 3.2, Operating System Use Cases. Let's begin. Your operating system allows us to interact with our hardware interfaces. Hardware interfaces are going to be all of the different components on the inside of your computer that perform some type of hardware or processing function. Some hardware interfaces that interact with our operating system include our CPU, memory, storage, as well as our expansion slots and buses that we find on our motherboard. Our operating system will also allow us to connect with peripheral interfaces. These will be items such as USB flash drives, optical discs, as well as cable connections such as HDMI, VGA, and DVI. Operating system software is defined by the term firmware. Firmware is going to be the software that is contained within your operating system that allows the user to control and monitor the different functions of the computer's internal hardware components. With firmware, we can control and monitor things such as CPU and memory usage, storage capacity, as well as the functionality of connected peripheral devices. Some common operating systems that you should be aware of are Microsoft Windows, Apple's Mac OS, which is a desktop operating system, and iOS, which is a mobile device operating system. We also have Linux, which is an open source operating system. We frequently call these distributions, as well as mobile operating systems such as Google Android, Apple iOS, and others. Operating systems have several common functionalities that you should understand for the exam. The first operating system feature is disk management. Disk management is going to be the utilities within our operating system that allow us to monitor and manage our storage devices. Operating systems allow us to set up and initialize storage devices to our computers. These can be internal storage, such as hard disk drives and solid-state drives, as well as externally connected storage, such as USB flash, optical drives, and standalone external storage servers. Disk management within an operating system also allows us to do a process called partitioning. Partitioning is when we take the available storage and we segment it into different partitions. Within each partition, we can identify the certain types of data and files that we wish to be stored within each one. Disk management also allows us to assign storage drive letters. These will be locations within the storage drive where we can identify specific types of data in a certain file or directory. Other features we can do with disk management include defragmentation, redundancy, where we have multiple hard drive or storage devices available for our machine, as well as the ability to create file volumes. The next operating system feature that we want to discuss is process management. Sometimes you also refer to this as memory management. Process management is going to be how our operating system can monitor the processing of our CPU and the allocation of our memory resources. When we're discussing memory, we're referring to RAM memory, random access memory. RAM memory is what we call a volatile storage. That means we're going to have to require a consistent power supply for it to work. Process management allows us to monitor how much processing the CPU is conducting at a certain point in time. One feature of process management is the ability to configure virtual memory. When you are working on your computer, all of the programs, applications, and files that you are accessing will be stored in our RAM memory. This allows us to access the open files and applications that we are running in a quicker time frame because our RAM memory is going to store the files that we are working with in the available RAM memory. Virtual memory occurs when our RAM memory is at full capacity to assign a certain amount of our permanent storage space on our hard disk drive to allow certain files and applications that are stored in memory to transfer over to the hard disk drive for a short period of time. As the files that are contained in the RAM memory are closed and available RAM is freed up, we can then transfer the virtual memory files from the hard disk drive back to our RAM memory. Another functionality of operating systems is device management. In many of your operating systems, you will have a utility called Device Manager. This is going to be a process that allows us as the user to monitor and view all of the hardware that is connected to our computer device. This allows us to view the different storage drives that are contained inside of the machine, as well as anything that is connected as a peripheral device. Device Manager allows us to view and configure things such as connected printers, as well as devices such as keyboards, mice, and display monitors. Within your device management console, you will see a drop-down list of all of the connected hardware components. And each hardware component that you see in your device manager will have different functions and configurations that we can view and modify to help us to improve our computer's system performance. Some common tasks that we do with device management include downloading our hardware device drivers, enabling or disabling specific devices, as well as creating notifications or alerts if any of our hardware components are malfunctioning. Another feature of operating systems is application management. This is where we can control the types of applications that can be downloaded to our computer, as well as managing applications through their life cycle. The application life cycle has several steps. The first is planning. This is where we can configure on our computer the types of applications that will be available for download. We will want to check the type of operating system we are running, 32-bit or 64-bit, as well as the vendor of the operating system, to see what types of applications we want to allow, as well as what types of sources or stores that we will allow our computer to download applications from. We always want to make sure that our computer is interacting with application resources that are trusted and verified. The second step of application management is acquiring the applications. This is where we are going to build or download the applications that we want to run within our operating system. The third step of application management is deployment. This is where we will make certain applications available to users that are running the operating system version on our computer devices. The fourth step is management. This is where we can monitor application usage, as well as making sure that we have the latest security drivers and patches to make sure that the applications we are running have the latest security standards from the manufacturer. And finally, we have disposal. Disposal is when we can close any unused or background applications on our system, as well as quarantining and removing any applications that have become infected with viruses or malware. Another operating system feature is access control. This is also used with a technique called ACLs, access control lists. ACLs are a feature within our operating system that creates permission levels for our users. Some standard permission levels are administrator, standard, and guest. A guest user is one that will access operating system resources for those that are going to be independent from the applications and data that are specific to our organization. We also have the ability to create standard users. This is where we can configure all of the different network users to specific resources and applications we want to allow to be run on their machines. We also can create administrative level users. These will be the individuals on our network that will have the ability to access and modify certain types of operating system features, such as our databases, Active Directory, and our file systems. This is a feature within our operating systems that allow us to close unresponsive applications to make sure that we can free up our system resources and prevent our system from freezing. In Microsoft Windows, this feature is called Kill Process. This is where we can access an application either through the End Task utility window or by right-clicking on the application and clicking the Close option, which will force the computer to close the application. Many times, if we close an application on our machine, we will need to reboot or restart the computer to make sure that the application has closed properly and that it can restart with a fresh resource of memory and storage. And now here in the last section, we're going to discuss the different types of operating systems that you'll see on different types of computers. The first operating system type to understand is a workstation OS. A workstation operating system is one that is installed on both desktop and laptop computers. The primary function of our workstation OS is to run applications and programs on our computer devices. Your workstation operating systems will have functionality with common devices such as keyboards, display monitors, a mouse, speakers, and others. If you have some type of specialized workstation, this will be a computer and an operating system that is designed for some type of high-performance computing task. Frequently, we see these types of workstation operating systems with graphic designers, as well as audio and visual workers. These would be people that are content creators. Many times, your workstation operating systems will have specific applications that are designed for tasks such as graphic design, computer-aided software, and 3D prototyping. Another type of operating system is a mobile device OS. These are operating systems that are designed for mobile devices such as tablets, smartphones, and health monitors. Your mobile device operating system will have a built-in wireless internet modem that allows us to connect to both 802.11 wireless and cellular networks. Your mobile device operating systems will also allow for device storage. This can be storage of data directly on the device or other functionalities such as SIM cards. The most popular mobile operating system at the moment is Android, which is a mobile device operating system you see with many different smartphones and the Google environment, as well as Apple's iOS, which is the operating system designed for Apple's mobile devices, such as iPads and iPhones. And the third type of operating system to understand is a server OS. A server operating system is one that is designed to run on server computers. Remember, servers are computer devices that act as a central location for our network users to access files, programs, and applications. Our server operating systems will provide an interface that our users can interact with the server computer to access certain types of information. Your server operating systems will frequently use a client-server configuration. This is where we will have individual users that we call the clients that will be working on their own computer devices, and they will be sending data requests directly to the server for file and application access. And lastly, we want to discuss hypervisors. Hypervisors are a specific type of operating system software that allows us to run multiple different operating systems on one machine. Hypervisors use a technology called virtualization. Virtualization is when we can take all of the internal computing resources, such as CPU, storage, and RAM memory, and we can segment them for the different operating system versions that we are running on our machine. We call the different operating systems that run on a device virtual machines. These are going to be software-based versions of different operating system environments. With a hypervisor, we can manage all of the different virtual machines that are running on a single device. So with a hypervisor, for example, we could take an Apple laptop, a MacBook, and we could install on our device hypervisor software that allows us to run a virtual operating system of Microsoft Windows, Linux, or another type of macOS version. That will conclude our discussion of Section 3.2, Operating System Use Cases. In our next episode, we will move on to Section 3.3 in the objectives and discuss software use cases. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.